We're getting close to 4:15, not yet. So we're going to go right to Ron Kamen to do his commercial on one of our sponsors here for Earthkind Energy. Ron, take it away.
Thank you, folks, for this quick opportunity to just share with you for a moment how to get paid to install solar in Westchester. What? Yeah, actually, this was a recent project in White Plains. So it was about a 6,000 square foot roof, a new roof, 81 kW or 81,000 watts. Total installed cost was going to be $200,000, but the incentive, the cash incentive that writes that down by 50% winds up reducing that price to $109,000. When you add in the federal tax credit of 26%, you do pay income tax on the NYSERDA piece of the incentive, so that takes a little bit away from the federal tax credit, but then you get accelerated depreciation and bonus depreciation. You write that piece off in a year, which means that the net investment is $10,400 on a $200,000 investment. When you then allocate a piece of the roof that you would have paid for anyway now to this project, what you wind up is being in the black. So if you haven't done solar yet in Westchester or in anywhere in Con Ed territory, seriously take a look at it. You're basically getting paid for it. You then generate $13,000 a year in savings. That winds up being $135,000 over 10 years, over $400,000 over the life of the equipment. And then if you take a look at other energy technologies, gas versus electric, what you find is that gasoline, even at $4 a gallon, which is now starting to look cheap, if you were to go to an electric vehicle and pay the highest Con Ed rates, you'd be 50% better off per mile with an electric car. And if you had that solar system on your roof or as a community solar system, you would actually be saving dramatically more. And the same is also true with heat, hot water, air conditioning on a 100,000 square foot office space. If your monthly cost was about $9,000 a month or $110,000 a year, if you went to an air source heat pump, you'd reduce that by 50%. And if you went to a ground source or a geothermal heating system, you'd be down over 80% in terms of your costs. So if you're complaining about high energy costs and you're concerned about the impact on your bottom line, don't leave money on the table. Come on out, talk. Let's maximize your ROI and let's save yourself some money with some clean energy technologies. Thank you very much, Michael.
Okay, well, we're getting close. Another 4 minutes to our presentation. We tell everybody it's going to start at 4:15, so we'll start at 4:15. But we're going to welcome you in to the rest of our audience of building design professionals interested in quality continuing education to today's credited presentation, which is geothermal heat pumps for the residential market. And hold on to your seats, Ron. Can you believe it? Another HSW AIA approved credited session. I can't believe it, but yeah, there it is. I'm your host, Michael Murphy, and on behalf of Murphy Brothers Contracting, thank you all for joining us for today's presentation, coming to you live on the ubiquitous Earthkind Energy Zoom platform. Murphy Brothers Contracting is known throughout the greater Westchester, Lower Hudson Valley, and Southern Fairfield region for award-winning residential and light commercial construction projects. The Murphy Brothers team would love to work with you. So visit our website at murphybrothers.com or call us at 914-777-577, and we'll start the conversation going on your next award-worthy project. A big thanks to our sponsors, Earthkind Energy and Bright Energy, as well as our media sponsor, which is Westchester Home Magazine. Write it down in your day timer if you have one. Who has a day timer? June 28th, the annual Westchester Home Design Awards at the Wainwright House in Rye, celebrating great architecture and design. So that's on June 28th for their annual Westchester Home Design Awards at the Wainwright House. And by the way, for our June presentation, we will be coming to you live, as in absolutely live, on June 27th at Westchester Magazine's headquarters in Rye. It'll be sort of a hybrid indoor-outdoor extravaganza that we're planning for you. So look for that invitation in your email soon, and we look forward to seeing you live at Westchester Magazine in June. Yes, there will be adult beverages, so bring your adult. Speaking of live, our presenter, who I will be introducing in a minute, will be holding court at our Murphy Brothers job site from noon to 12 p.m. or to 2 p.m. tomorrow to show you how geothermal systems work. So come one and come all to 7 Bay Avenue in Larchmont, New York, to see the great and powerful Mike Murphy pontificate on the design and benefits of geothermal systems. Refreshments will be provided by our good friends at Warm Board. If you need directions, call me or email me soon, because it's all about to happen tomorrow live at 7 Bay Avenue in Larchmont. If you want to see a geothermal system, and this is quite a geothermal system. This is a 20-ton system, 10 wells. It's something to see. And Mike Murphy will be there to tell you all about it, why, the how, and why you should do it for your next project, whether it's residential or commercial. Now, if you would like AIA credit for this session and you haven't already, and you know who you are, not you, Steph, I got your information already, but send your 8-digit AIA number. All in attendance will receive by email an official attendance certificate courtesy of the good folks at Climate Master. So if some of your 8-digit AIA number, if you haven't already, certificates are going to come from Climate Master. During the presentation, Mr. Earthkind Energy, Ron Kamen, will be collecting your questions for our presenter in our official Zoom chat box, and we'll tackle these questions after the speakers finish with this presentation, which means you're all on mute, so sit back and enjoy the HSW AIA accredited portion of our presentation, which is geothermal heat pumps for the residential market. Mike Murphy is the manager of National Residential Distribution at Climate Master. Mike is an HVAC industry veteran specializing in providing indoor comfort solutions for more than 4 decades. As a residential geothermal manager for a major manufacturer, that being Climate Master, Mike strives to provide best-in-class products that deliver home comfort, low operating costs, and reliable infrastructure to serve the building for generations. Coming to you live, coming to you live from Murphy Brothers Contracting's own conference room. It's your favorite geothermal expert and mine, Mr. Mike Murphy. 4:15, recording, Ron? Are we recording?
Yes, sir.
Take it away, Mike.
Michael Murphy, thanks for that introduction. Jordan, Bonnie, Laura, great products, great presentation. Thank you. I would like to talk today about geothermal heat pumps and their uses both residentially and maybe we'll delve into commercial as well. This is an AIA qualified product that I'm presenting to you today, and we will attempt to educate you and make you comfortable with geothermal heat pumps. They are sustainable, affordable, efficient, and they're proven. We have a video ad that says in 1957, when the whole world was looking up at the first orbiting satellite, we were looking down and creating our first geothermal heat pump. Part of the issue with this technology, this heat pump technology, is the upfront cost of the ground loop. So this course today will explore geothermal systems, loop options to control the expense or the initial cash outlay of investing in geothermal. I will show you how an air source heat pump, which many of you have in your homes, and a ground source heat pump differ in how they are alike. This is an introductory course registered with AIA. You will get one learning unit, health, safety, and welfare. And as Michael mentioned, I will be compiling the list, submitting them to AIA. And for those of you members who want certificates, those will be sent out to you. Those of you that are not AIA members, certificates will automatically be sent out to you.
Michael, did you want to start your video, Mike Murphy?
Not necessarily.
That's up to you, I guess.
Thank you. These are requirements that I cover prior to going into my presentation. This does not include any content that may be deemed or construed to be an approval or an endorsement of AIA. So I am speaking to you today, not as a representative of Climate Master geothermal heat pumps, but as an advocate and a passionate advocate of the technology that is ground source heat pumps. The principles of ground source heat pumps will be covered today. as will a comparison between what many of you have in your homes, and which is an air source heat pump, and a ground source heat pump. I will also try and demonstrate how controlling the cost of an installation can be done by consciously and competently choosing how many linear feet of geothermal piping is put into the ground, thus saving you energy, and show you that we as an industry encourage designers to put ground loop into the, or heat exchanger into the ground based upon the load or the requirements of the building and not rules of thumb. We would also like to demonstrate how this technology fulfills requirements, trending requirements of beneficial electrification, and how reducing operational costs, increasing life cycle or equipment life cycle as compared to an air source product. I do pretty much handle most states in the union, and there are coastal areas that have to replace their outdoor condensing sections every few years. A geothermal heat pump, if you would like it to be, is all in the building so that we are not exposed to salt spray, dramatically increasing the life expectancy of our product. Geothermal heat pumps are certainly scalable and also considered to be a renewable energy. The photograph on the left is the largest privately owned island in the Southeast, connected by a bridge. It is comprised of 5 outbuildings or 5 buildings and 8 geothermal heat pumps. That job required a vertical loop system. So we have 38 vertical boreholes doing Little Hawkins Island compound in Southeast Georgia. The photograph on the right, or the home on the right, 1,800 square feet or thereabouts. 3 vertical boreholes will allow the homeowner to reject the amount of heat that structure takes in on an hourly basis into water, and have that BTUs, that heat, be rejected into the ground and maintain the required, whatever that may be, indoor temperature at the thermostat. Geothermal heat pump technology is recognized by the federal government as a renewable energy. Its purpose is to transfer heat from the earth to a building, or from a home building to the earth. Doesn't make heat, it just transfers heat. It's a technology that functions at very high efficiencies, regardless of outdoor temperatures. We rely on stable ground temperatures. So the fact that we have a design temp of over 100 degrees in some areas of the country, or a design outdoor temperature in the -20s, doesn't affect geothermal heat pumps with regards to their efficiencies. If you think about it, air source heat pumps or air conditioners are least efficient on the days of the year that you need them the most, or to rely upon them to be somewhat efficient, whether that be 95 degrees outside or 90 degrees or very, very cold. Our technology isn't affected by that. It's a scalable technology, as I mentioned earlier when showing the 2 homes. We have 900-foot Habitat for Humanity structures, as well as office buildings on ground loops, state capitals, and the largest geothermal commercial project in the United States presently is Ball State University. My opening slide was of Norton Commons in Louisville, Kentucky. That is the largest residential community of geothermal heat pumps in the country. Geothermal heat pumps are flexible. We can use them to condition air. We use them to warm floors in homes or warm floors for chicken raising, swine raising, wine production. Anything that is done with a water source heat pump is going to be more efficient than an air source product. As a matter of fact, the EPA has said, I believe this was 1992, geothermal heat pumps are the most energy efficient, environmentally clean, and cost-effective system for heating and cooling buildings. So in a residence, what do the differences look like? On the left-hand picture, we have a ground source heat pump, right? Picture, an air source heat pump. So on the right, we are looking at either an air handler, electric air handler, or a gas furnace. And we have copper tubing connecting an indoor evaporator coil, and you see that in your own basements or homes. And that connects to a condensing section sitting out in your yard. And then we have ductwork, supply and return ductwork that is delivering conditioned air to the living space. The photo on the left, exactly the same ductwork, because we design using the same CFMs, if you will, the CFMs per ton. And then we have what looks like a gas furnace, but in fact is the entire ground source heat pump box. In the bottom of that box, we have a compressor and the electric components. In the top half of that box, we have the air delivery system, or the motor and the blower assembly. Everything that you use to heat and cool that structure is in that box, so no outdoor unit is needed. Those black rubber tubes that run from the piece of equipment up to the ceiling and then outside, that is high density polyethylene pipe and is connected to the ground loop of the geothermal system. You are seeing water in the floor, on the floor of this new installation, because it was recently underwent what we'll call a flushing procedure, which is what we do before we commission the piece of equipment. And the flushing of our ground loop, and then our heat pump, and then our ground loop and heat pump together is needed to get all of the air out of the system. So air is the enemy of a geothermal heat pump system, and we need to rid that indoor, outdoor, both combined, rid it of air. So it takes up the same floor space, each one of these technologies. They both operate using the exact same compressor. It could be a single stage Copeland scroll. It could be a two-stage Copeland unloading scroll compressor. We use exactly the same thermal expansion valves, same reversing valves, same refrigerants. The only difference between the two technologies is the ground source heat pump has no outdoor unit. It has no freon lines running from the condensing section to the evaporator coil. And really, because of those facts, it has less maintenance. We are eliminating outdoor condenser fan noise, condenser compressor noise. We are eliminating a fossil fuel. Therefore, we are eliminating carbon monoxide production and carbon dioxide production. We use far less freon in a packaged ground source heat pump because we don't have to fill refrigerant lines with refrigerant. So we have ounces of freon in our system as opposed to potentially, oh my goodness, 8, 10, 12 pounds of refrigerant. And again, both technologies use the same R410A refrigerant presently, and most manufacturers are going to a new refrigerant to satisfy the government, and that is R54B, and we will be using that same refrigerant up until the date that is the sunset date for 410A, and then it will be solely R54B. Some additional differences. Our product, our ground source heat pump, is rated with an energy efficiency ratio, or an EER, as opposed to what most homeowners are comfortable with, a SEER rating. We don't have a seasonal energy efficiency ratio or rating because of our relatively constant ground temperature. Our outdoor air going up and down in temperature has no bearing on our energy rating because we're using the ground. We have no visible outdoor unit. It's buried in the yard. And the efficiency, again, doesn't drop when the weather is at its hottest or its coldest. You do hear now a lot about cold weather heat pumps, but I would encourage you as a homeowner or an architect, engineer, to look at cold weather heat pump efficiency as the outdoor ambient temperature drops in the longitude and latitude that you call home here in New York. The unit that I picture here is suffering from a malfunction within the defrost cycle of the air source heat pump. And it's a little bit important that we understand what a defrost cycle is. A heat pump, when it is heating the home in the wintertime, needs to get rid of the buildup of frost that occurs on the outdoor coil when it is in the heating mode in the wintertime. So we reverse a valve and actually cool in the cooling mode, use the indoor heat to melt through the refrigerant lines the frost that's on the outdoor condensing section. Absolutely inefficient to go into the cooling mode to allow the heat pump to go back to heating your home. Ground source heat pumps don't suffer from the fact that air source does need a defrost cycle. So an air source heat pump, it transfers heat, and it does an okay job of that down to certain temperatures or up to certain temperatures. Ground source heat pump doesn't make heat. It uses conventional heat pump technology, compressor, reversing valve, thermal expansion valve, to transfer heat from the earth to the home or the structure. Efficiencies, again, are not dependent on outdoor ambient temperatures. Properly designed, and we encourage, don't stray from the design requirements of a structure with a ground source heat pump, because if we start straying from proper design, in the end, we'll have an unhappy homeowner. Properly designed, it maintains the efficiency during extremes. Properly designed means designed to the heat loss and the heat gain of a structure at a specific temperature. It is a very, very simple technology. Contractors are sometimes afraid of our technology. And I will say to them, folks, you have been working on heat pumps your whole life. The only thing that differs with our technology is the compressors in the house, and we don't have an outdoor condenser fan motor. We don't have the noise associated with it. All that's in the house. Don't be afraid of it. Think about it, and you will understand that this is far simpler than a conventional heat pump. It's a renewable energy, and it is classified as such because it uses the sun warming the earth as the basis of its operation. So most of the heat that is generated by the sun is absorbed into the ground, and there are clouds and reflection and surface reflection, but most of it is absorbed into the ground. Below 5 feet or so, the earth stays a constant temperature. So you'll see by this chart that you will hover somewhere between, I don't know, probably 45 and 52 degrees as your constant stable ground temperature. If we were able to use an air source heat pump with constant temperatures of 45 to 52, you would have a very efficient product. Unfortunately, Mother Earth doesn't cooperate with us, and we see outdoor temperatures that go into the 90s or drop down into the minuses in many areas of the country. Think of purchasing a kilowatt of energy from the grid to fire off the electrical components of a ground source heat pump. So we're using that kW of energy to fire off the blower motor, the compressor, and the loop pump, and we're using that kW to extract or reject BTUs from the earth and delivering to the structure 4-6 kilowatts of energy to the house. Yes, that means our technology, properly designed, will operate at efficiency levels exceeding 400%. As a contractor years ago, prior to the more adoption or acceptance of ground source heat pumps, I would propose to homeowners, I don't know, an 80% efficient furnace. Then we got into 90% efficient furnaces, and we went up to 95% efficiency. As a contractor, I was introduced to ground source heat pumps and was able to talk about efficiency levels back then in the 300s. And now with scroll technology compressors, multiple stage compressors, variable speed compressors, our efficiencies are staggering. And any improvement in heat pump technology will benefit both air source and ground source, but exponentially more ground source heat pumps. Again, we are using this indoor unit with a pump to circulate water. And in your area of the world, we need some sort of antifreeze in that water. It may be methanol or ethanol or food grade propylene glycol to keep it from freezing. But that is circulated through the piece of equipment to extract or reject heat, pick up heat from the house, put it into the ground, pick up heat from the ground, put it into the house through a water-based system. Before I get into the different ground loops, I do ask folk who are struggling to grasp this concept to consider how long a pan can sit on your stove and still be very warm to the touch. That same pan run under any temperatured water can sink heat out of that pan in seconds. Water is a great medium to transfer energy, to transfer heat. And we're doing this with about 4 different types of loop systems. Very common is vertical boring, where we have a drill rig that drills a 4.5 or 6 inch diameter hole in the ground to various depths, depending on the geology that the home is located in. And that is probably the most expensive ground exchanger that we could put in, because it does require expensive equipment to drill boreholes. Another loop is a horizontal one. We need a little bit more real estate to dig down 5 feet into the ground, where we can bury a series of ground loops functioning identically to the vertical bores when designed correctly. Probably the least expensive ground loop would be one that we would sink into a pond or hang underneath a dock in deep water. A very efficient and relatively inexpensive ground loop. We also have what we'll call a pump and dump, because you have heard of that term before, chances are good. Many municipalities are putting high restrictions on this type of ground loop, if you will. Some are making us, as an industry, put the water that we extracted from the ground and run through the piece of equipment back into the same aquifer that we took it out of. Other municipalities and DNRs are saying, no, we don't want any open loop systems in our municipality, and we must then consider some sort of ground loop. Some photos of the different loop fields. The upper left is the Juneau, Alaska airport. The ground loops are buried under the tarmac, and that ground loop is then connected to all of the terminals in Juneau's airport to cool as well as heat the structure. The upper right picture is a 3-circuit, 6 pipes, 3 supplies and 3 returns into the same trench, which is a perfectly acceptable ground loop design. We could put 1 circuit in the trench that you're looking at, 2 circuits or 4 pipes, and we have modeling up to 3 circuits, 6 pipes in the same trench. We need some more real estate to do that, however. Bottom left photograph, an up and coming use or new ground loop, if you will, is horizontal directional boring. That is very unobtrusive to a yard. We would dig approximately 4 foot by 6 foot hole in your yard, and then insert that drill head there and go down maybe 8 feet, 10 feet, pop up a couple of 100 feet away, maybe go underneath the house, go underneath the driveway to some area of the property from front to backyard, affix some geothermal pipe to it and pull it back through. And that 4 to 8 foot pit would then become where we manifold all of those pipes together. And then backfill that 1 4 foot by 8 foot pit, if you will. The bottom right, this is a 1,500 ton air conditioning application in a cold weather climate. Each one of those circular sets of high density polyethylene pipe is a ton of product, and we would float those out and then sink them in 8 feet of water. Any of these ground loop designs will provide a homeowner with the almost exact same bill at the end of a year, if properly designed. So one loop isn't better than another loop. It just depends on what would be the most cost-effective loop to put into a footprint of a home to do the job. That is what we tell contractors is the best loop. Let's go after the least amount of money installed for the homeowner. If you can fit it in the design, do it. This is what our pipe looks like. High density polyethylene. It is a fused product. In other words, there are no mechanical joints that are buried in the ground. They are all heat fused. So we use several different types of technology depending on the diameter of the pipe to join two pieces of pipe. If it's a small diameter, meaning 3/4 of an inch or 1 inch, 1.25 inches, we will use just a plain old portable socket fusion set. I have one of those in my closet at home that I use on residential jobs when I'm going out to help contractors for the first time. We get into bigger diameter pipes. It just takes too much oomph to get the pipe properly joined or seated. So we will use different processes to join a 4-inch diameter pipe or a 6-inch diameter pipe. You may have seen some, oh gosh, up to 18-inch diameter pipes getting used in your neighborhoods to carry sewage, to carry electric cables. They're using high density polyethylene because it is borderline permanent, has a very, very long life expectancy. I'm not real sure that we know how long it lasts, but so far we're talking about 100-year lifespan. It doesn't deteriorate. So the deeper we go, the larger diameter of pipe that we would need to use in your yard. So if we are confined or constrained because of a backyard footprint, but we need to get, 900, 1,000 linear feet of borehole in the ground, we could do 5 200-foot boreholes, 15 feet apart or so, or we could do 2 500-foot boreholes, accomplish the same thing, do a little bit different diameter, larger diameter pipe, and then our pumping requirements may be a little different as well, but essentially that's the same heat exchanger buried in the ground. Every manufacturer of pipe, I'm sorry, of geothermal heat exchangers has design software that will assist your contractor in selecting the proper capacity of product, as well as the linear feet of pipe that needs to be put into the ground. And all of our software will allow them to test drive different types of ground loops, be it vertical, horizontal, directional boring, pond, to assist them in choosing how much pipe they need to put into the ground and how deep they would need to drill in order to reject the amount of heat or extract the amount of heat, depending on whether it's a dominant load heating or dominant load air conditioning. And we all have this software. This software is also available for commercial projects. Most schools that are being built today are being built with geothermal heat pumps, and we are hiding the ground loop underneath parking lots, underneath football fields, because we can bury this product. We should never, ever have to visit it again. We don't bury a leak, and unless there's an accident with someone digging into it aggressively, you'll never have to access that buried loop again. So we all should use design software to assist with the load, figuring out how much heat we need to put into a structure or take out of a structure, and then how much linear feet of borehole do we need to drill, linear feet of trench do we need, whether it's one circuit in the trench or 3 circuits in a trench. No rules of thumb. Our tax credits are changing, at least in as it is presently written into the Internal Revenue Service tax codes. A couple of years ago, we transitioned from a 30% federal tax credit with no cap to a 26% tax credit with no cap. And that 26% is going to be with us until 2022, when it drops down to 22% through 2023. This equipment does not have to be installed in a primary residence. It could be in your primary residence, as well as vacation homes, et cetera, et cetera, et cetera. And I would, in spite of what I may say here on this slide, I would always encourage homeowners to discuss this with their accountant. But we do know that the tax credit cannot be claimed on equipment that is used to heat a swimming pool, hot tub. We cannot dig a pond and claim a 26% tax credit on the cost of digging the pond. I should spend a minute or two indicating what's going on legislatively in Washington now on behalf of our industry. We, at one point, meaning the geothermal technology, were included in the Build Back Better bill. Obviously, that has not gone well for current administration. Our tax credits our bill has been moved, and our lobbyists are very encouraged that we will see a 30% tax credit extension for residential product for an additional 10 years. I think the biggest win for the industry, however, is on the commercial side, where instead of having a 10% tax credit, current bill wording, and one that's been accepted by both Republicans and Democrats, indicate that there will be a larger tax credit for commercial applications extended out to 10 years as well. There is some other wording in the bill that is rather exciting. And I guess suffice to say, we as an industry expect some sort of movement by the end of July of this year on the efforts of the lobbyists to extend this tax credit. Obviously, there are utilities, there are states, there are municipalities that are all interested in embracing renewable energies. A very strong website that we have been able to rely on in the past, facilitated by North Carolina State University, is dsireusa.org. In working with them in recent months or so, I'm finding that they're changing so quickly state by state that North Carolina State is not able to keep up with the changes with the offerings of the particular states. So it is best to keep an ear and an eye towards activity in your state legislature. I understand that New York has just had some movement involving a 25% state tax credit. I think this technology is worth eliminating, if you will, the cost of the ground loop. If you do that, the replacement of a heat pump versus an air source heat pump versus a ground source heat pump is going to be really close if we can negate the cost of the ground loop. So keep your eyes peeled for stuff coming out of Washington on behalf of our renewable energy, and some additional websites that can be helpful to you include New York Geo, Ron's website, earthkindenergy.com, our industry advocate and the one that does our efforts in Washington, the Geo Exchange organization, a very good website for homeowners. And then the big three in manufacturing of residential product in the United States are Climate Master, Water Furnace, and Enertech. We all have strong design software. We all want to see successful geothermal installations undertaken, and all three of us will do what we can to ensure that contractors are comfortable with how to do this precisely. But it's not hard. It's just we need to be a little precise with it. How to do this precisely so that it is good for the homeowner, good for the utility, good for the contractor, good for the environment. It is a product that warrants some consideration. So with that, how about a question or two? One other thing I should note here, I've got on my slide a NEBA company. NEBA is a strong renewable energy advocate internationally. They did purchase the three companies that I had mentioned previously: Enertech in 2012, Water Furnace in 2014, and Climate Master in 2016. So although we probably consider ourselves sister companies, we are competitors. However, I think all three of us are more after embracing the technology than we are saying, hey, I'm better than you are, because I don't know that that's a great statement. Who's got questions?
Great. We got a bunch of them, Mike. And one comment first. New York State did pass that 25% state tax credit. Thank you, Scott Smith from NYSERDA, for making that clear to everybody. It's a cap of $5,000, but that's a nice another $5,000 on top of the federal tax credit that everyone in New York State can now claim. Thank you very much. Mike, one quick question. So tomorrow you're holding court, as the other Michael Murphy says, at an geothermal installation. Why should people come tomorrow and talk to you versus just being on this webinar today?
Well, it will show them how versatile this product is. They can look around this beautiful home, take a peek out the backyard, and see the potential of the landscaping without a condensing section. The heat exchanger in that home is buried in the yard. You'll never see it.
Excellent.
We are radiant floor heating. We are, and that's heating now. We are air conditioning the home. It is a very interesting use of the available technologies to heat a home. Not only is there geothermal, but there are some other interesting aspects going on in this home that I think any architect would say, that's pretty cool. I think I might investigate that a little bit more. It's worthwhile, and if you can, please come and spend an hour with us tomorrow. I'll be in the basement. There will be other people hanging around the house. Food, yeah, it's a worthwhile hour. Please.
And if I might add, it's a 20-ton geothermal system, 10 wells drilled, almost 500 feet per well in the driveway. You'll never see them.
Excellent. So, okay, piles of questions here. So first, how are the fuse joints tested?
We test them with 100 pounds pressure water. First of all, that's the safest way to test. Testing with air can get dicey if an accident were to occur and the pipe would get loose. 100 pounds pressure with water will show a leak rather quickly. And we prove that time and time again in our classes, that the only way we recommend testing pressure in, or the integrity of each circuit is with water.
And what is that PSI for the fluid inside the pipe after you do the testing, et cetera?
Well, we say 100 pounds. The pipe is pressure rated higher than that, but a leak will manifest itself rather quickly at 100 pounds. What will we then use as an operating pressure?
Exactly.
Pumps will operate 2 pounds pressure. We say, hey, let's put 40 pounds of pressure in your ground loop. It's a nice middle of the road pressure. We can do it with the home. We need to fill our loop field with good water, however. So if we have crappy, excuse me, that's not a good word to use. If we have suspect well water, we shouldn't be putting that in the loop field. But 40 pounds is a pressure that will keep you out of trouble.
All right. So there used to be a concern that cold temperatures would require backup systems. Is that still recommended or not?
In this area of the world, probably. We would rather not handle 100% of the heating load in a place like New York, because we will most likely find that we have oversized the cooling. And when we oversize a home's cooling system, we have difficulty controlling the humidity. So on most systems in the north, we have a geothermal heat pump, and we'll take it down to whatever design temperature we want. It probably isn't going to 0 because, oh my goodness, we have to air condition in New York or Cleveland, Ohio. So a backup heat does help from the standpoint of keeping an eyeball on year-round comfort.
Interesting. Can you connect a geothermal loop to units in individual rooms?
I'm not certain I understand the question. Let's say we have this 10 bore field system that is on bay. We could have one unit doing one room hooked to that ground loop, if that answers the question.
So let's say you're in a multifamily apartment building. How would you do the geothermal hookup to each apartment then?
Well, I'm hesitating because there is how do you separately meter that? However, if we had a multi-unit, let's just say we have 5 suites, each unit had its own pump, its own suite, and we could meter that piece of equipment. We would just hook up to that district loop, if you will, and draw the heating or cooling BTUs off of the ground loop. We're doing that more and more and more. We'll call that district space conditioning.
When is a treated system recommended versus plain water? Or is it always antifreeze, or is water always an option?
Again, I guess it depends. I live in Southeast Georgia. I do not have any antifreeze in my ground loop. All of my pipe is buried, except what comes up and into the unit in the garage. Rarely will I see 32 degrees. So I don't have any antifreeze and I'm comfortable with it. You go a little bit north, maybe into Charlotte, and we would recommend some antifreeze in that loop field. and we would put antifreeze in there to not only protect the loop from freezing, which probably would not happen in Charlotte, but protect the piece of equipment in case we lost all power, like happened in Texas. We certainly would not want to blow up pieces of equipment or ground loops. If it froze in your garage or on the way to the header pit, we would have an expensive problem, but mostly to protect the equipment.
All right, so there are some competitors out there who are, doing extensive marketing for low-price geothermal systems. They're doing an excellent job at marketing it. What would you say would be some of the concerns with some of the products you're seeing out there versus, Climate Master and some of the other more established brands?
Our technology should be no more expensive than, let's just go with a gas furnace, an outdoor condensing section, an evaporator coil, and a set of refrigerant lines. Price up a geothermal heat pump. We should be very close in price as a technology, regardless of who made it. When you say low price, I don't know of a manufacturer that is dramatically more expensive than the one I work for, or dramatically less expensive than the one I work for. If an installation is quoted to a homeowner and it is dramatically less expensive, I would question the contractor and their ability to install it correctly. And I take that to mean precisely do the design work, spend the time. It is not a hook it up and go. It needs to be flushed correctly. All of that takes time. If someone's dramatically cheaper in any trade, I think it just deserves some extra investigation by the homeowner to determine why one manufacturer or one job is dramatically less than another. I don't think it should happen. If you're telling me that it does, as a homeowner, I would love to sit down and figure out why, but I don't think it's the equipment.
Right. For clients that are concerned about leaks, to defeat freezing, is salt water an option? God bless you, by the way.
Gosh, you're asking hard questions. Copper and salt don't play well together. Copper nickel, and these are heat exchanger materials. Copper nickel heat exchanger and salt water don't play well together. I would say salt is not something that we want. I'm not sneezing. I just got delivered tissues. Okay. Thank you for that.
Okay, so no salt water. Okay.
No salt water. Salt water is our enemy.
Okay.
Now, I do have some saltwater applications down in Florida. It's a little bit brackish that they are yanking out of the ground. I said, please, let's have an intermediary heat exchanger. If you're heck bent on a groundwater application, let's run that salt water through a plate and frame heat exchanger so that salt water never communicates to the geothermal heat pump. So it is done, but you're adding a little bit of an expense. And very frequently that plate and frame heat exchanger has some titanium involved in it or some stainless steel involved in it. And I would encourage anyone with an open loop system to get their water quality tested, compare it to the manufacturer's accepted parameters for water quality. And if you need to use an open loop system and your water quality is not what the manufacturer wants, please invest the money in some sort of heat exchanger, intermediary heat exchanger.
Cool. There's one of the questions is somebody spoke to someone today who said that they can get everything they need about their house, the size of the equipment, off of the internet. How is that possible?
It is possible. But I would caution, let's design it correctly first. And if you want to DIY it, let the buyer beware. I don't know how many of you saw the color of my hair, but it's pretty gray. I'm really 35, and much of that grayness is due to fielding questions from folks that did not design, install precisely. And yes, you can buy anything off the internet. Absolutely anything, including turnkey geothermal. And if it is done precisely, I don't think you'll have a problem.
Okay, so folks, again, tomorrow there's an on-site demonstration of a system, a 20-ton geothermal system. If anyone's interested, contact Michael Murphy, and he will arrange all the information that you need. So tomorrow from 12 to 2 in Larchmont. All right, another question. Isn't it possible that the system could affect the environmental temperature of a pond or a small lake?
We ask that pond loops be put into a pond a half acre or larger, and 8 feet deep or deeper. If that is done, no aeration, please, for winter months. Keep that ice cover there so that our temperature below the ice thickness, if you will, is pretty close to a constant 39. We have done both heating and cooling water temperature studies and have gotten the blessing of, we haven't been turned down by any DNR by putting a heat exchanger into a pond. That heat in the cooling mode, if you will, because the questioner asked about getting it warm, it will rise to the top, much like thermal energy in a spring-fed application will rise to the top, and it'll go away overnight, the heat. We won't heat the pond up.
Okay. So someone has a geothermal system now. Can they still get the tax credits and the rebate to replace the system?
Sure.
Okay.
Yes.
And then my understanding is that if someone starts a geothermal construction this year and gets at least 5% of the cost in it, they should be able to claim the 26% federal tax credit even though it's changing next year and they complete the system next year. Always check your tax advisor, but I do believe that's the case. It's over 5%, right, Michael?
I'm not going to comment on that. I'd say go to your accountant.
Go to your tax advisor.
And have them look at the code and make the call for you.
Okay. How much should a system cost?
That's the $64,000 question, and that's probably a good guess. It'll cost $64,000 and up. I'm kidding. Ron and guys that are in attendance, and I thank you all for your interest in this technology. It will depend on drilling costs or the cost of getting the heat exchanger put into the ground. So drilling is more expensive in some areas of the country. I just left Oklahoma last week, where they are drilling and grouting. In other words, filling this annular space, this borehole, up with a thermally conductive grout for $6 a linear foot. Where I live, $22 per linear foot drilling costs. So there are some dramatic swings in drilling, and I feel it's due to the maturity level of the area of the country. The Midwest was the birthplace of this technology. So PA, Ohio, Michigan, Illinois, they have some relatively inexpensive per linear foot drilling costs. Down in the Carolinas and Georgia, it's relatively new. The drillers aren't comfortable with it. They're water well drillers, so they charge more. I don't think that answered anybody's question. And I'm not trying to dodge the question of how much does it cost. But it certainly does depend on the house.
All right, I have someone said that a recent geothermal system proposal for an 1,800 square foot house in Ulster County was $27,800. So interesting response on that one. I have cold spots in my house. Will this new system make them go away?
In a word, no. We have the same air distribution system as your existing unit does. The only thing that may make that a little more palatable is a multi-stage unit that runs a little bit longer, therefore heating or space conditioning all areas of the house a little bit longer. However, I would absolutely share that comment with your heating contractor, because they better ask you about your existing comfort level before they go and recommend any indoor comfort system to you, be it conventional furnace air conditioner or a geothermal heat pump. That's a 101 question for a contractor, and anybody that doesn't attempt to cover that with you, I would sort of say next. It's important.
All right. I have a well that I use for house water. Can I use this well for geothermal as well? Awesome.
Mm-hmm. Well, yeah. Gallons per minute. We need, let's just say 2 gallons per minute per ton. So we would like you to be able to space condition your home when you have all the in-laws and outlaws in your home, taking all 3 of your showers up, and you're doing laundry, et cetera, the well needs to support everything. If it does, and you have water quality, because our 2 requirements are water quality and water quantity, absolutely the same well can be used.
So one of the challenges, though, with that type of open loop is both getting the water in, so the quantity and the quality of it. Then it becomes, if you have an open loop as opposed to a closed loop, you'll need filters that basically clear out, that need to be changed.
Oh, yuck.
Right?
If you need filters on your open loop system, I think you're probably not a candidate for an open loop system.
Right. And then
unless you are so diligent about having those filters changed, I just don't, that usually doesn't end well for folks that feel they can do it.
Right. Okay. Yeah, I mean, open loop, I would just personally stay away from. So, but that's just my particular piece because of all those potential issues. And then just dealing with the dumping of the water is another one too. So, I have another comment that when one renovates and insulates close to passive housing, only 2 wells are needed for an average house. So that's pretty good. All right. Last question. How long does it take to install a system? Second to last question.
Yeah. Gosh, I'm just saying it depends too frequently. At this point, drilling is a bottleneck for our industry. And I don't think that New York is any different than any other area of the country. So I think at this juncture, we need to be prepared to wait on the driller. And then once job starts and stops, shoot, I got mine installed in 2.5 days. Drilling transitions to existing supply duct system. And that isn't always addressing the homeowner's needs. But frankly, I could not replace all my ductwork at the time I did my geothermal. So I only recently swapped out all the ductwork in the attic for, you know, a lot of money. So, no, it days.
Okay. Someone's been looking at your website. Is the variable speed system better than the two-stage system?
All manufacturers have a variable frequency drive compressor product that I will use the term load matches the house. So if you need, because it is 50 outside, 18,000 BTUs of heat, that variable speed compressor product will put 18,000 BTUs of heat into that living space. It gets colder and you need 30, it'll put in 30. So the bottom line is, yes, a variable speed compressor product with properly designed ductwork, absolutely heat and cool your home more accurately than a single stage product, which is pretty much a dinosaur at this point, or a two-stage product, which should be, in my opinion, most people's entry-level product, regardless of the technology, whether it's a gas furnace, a multi-stage heat pump, it at least needs to be multi-stage. But variable speed is the future of all industries. Indoor comfort.
Excellent. Thank you so much, Mike Murphy of Climate Master. Thank you all for attending. I want to invite you again tomorrow, 12 noon, at 7th Bay in Larchmont to see a 20-ton geothermal system along with other technologies, ample parking, refreshments, including sandwiches and drinks, but supplied by a warm board. It's going to be a beautiful day for a geothermal tour. Would also like to thank Jordan Prentice, founder of Componia Innovations, for her excellent presentation. Mike Murphy, great job as always. Thank you, Climate Master. Thank you, Componia. Thank you, as always, Murphy Brothers Contracting, Bright Energy, Bot & Company, Center for Sustainable Development, Lauda Creative Group, Westchester Home, and I'm Ron Kamen from Earthkind Energy Consulting. Thank you all for another Murphy Brothers Contracting excellent continuing education series, and have a great day all. Hope to see you tomorrow. Michael, any last words?
Ron, I think you said it all. Thank you all. Hope to see you tomorrow.